Hadoop as a service, but actually more. It's a massively parallel compute as a service. With that, you can create transient clusters that come and go, or clusters that you keep running 24/7. EMR includes a whole bunch of applications, 17 of them to date, and we continue to add to those. Flink is now one of those. It's easy to use. You can very quickly, in less than a minute, specify what you want in a cluster and spin it up. It's fully managed, so it takes care of spinning up the underlying servers, connecting them, configuring them, installing the software, and making them usable, as well as managing the collection of clusters, or a collection of nodes as a high-level cluster abstraction. It's on demand. The pricing is on demand by default, but you can leverage reserved pricing and also easily take advantage of spot instances or unused capacity that we allow customers to bid on. It includes a variety of persistence layers, HDFS, the common Hadoop one, S3, which gives you tremendous benefits, gives you a low-cost storage with a whole bunch of benefits like durability and life cycles, et cetera, et cetera. And if you need lots of local storage, you can increase the node disk space with elastic block storage. And importantly, it provides end-to-end security. So you have the means, should you choose it, to accomplish access controls over who can control the EMR clusters, firewalls, and VPCs, subnets, ingress, egress. You can control all that, but also importantly, encrypt from end to end in order to operate EMR. Amazon Elasticsearch service. So this provides and helps you run an Elasticsearch cluster. It reduces the work required to do that. Elasticsearch, of course, is an open source application that generates indexing of streaming documents and messages, etc. It includes the complete stack, the Elasticsearch, Logstash, and Kibana stack. It's, as I said, fully managed service, zero administration. You'll see how straightforward it is to manage. And highly available and reliable, and it scales quite well. All right, so let's jump into the demo. For that, I'm going to switch to my web browser. Just bear with me. Okay, so if you remember, the key components we're going to deploy are Amazon Kinesis stream. That's up, and then downstream of that we'll have EMR with Flink, and then downstream of that we'll have Elasticsearch and Kibana. So what I'm going to do is show you how you would deploy each of those. It's very easy. So here we can just browse or type in Kinesis, and so here's Kinesis. So we switch to that. We're going to use Kinesis streams. There's Kinesis Firehose and Analytics, which you can also use. Let me that's fine. I'll create a new stream here. So we need to give it a name. So we'll say Taxi Analytics, or we'll just call it Taxi Stream. All right. And so with Kinesis, you have upstream producers, some source generating data. As I mentioned, you have your capacity determined by shards, and then you pass on the data downstream to some consumer, which in our case will be EMR. So what we're going to do is just use the estimator here. The average record size, we'll say, is 1 KB. Let's go with 15,000 records per second. There's going to be one consumer application. That'll be our Flink application. So that generated a calculation of 15 shards, and we'll go ahead and use that value. It plugs them in below, and then we create the stream. And that's it. That is now spinning up the taxi stream. It'll take 30 to 60 seconds. In the meantime, we'll now move on to EMR. So let's go to, there we go, EMR. All right, so let's create a cluster. Now there's a simple view of EMR cluster creation and then an advanced one. We're going to switch to the advanced one because we want to be somewhat customized here. And so what we're going to do is we don't need Pig, we don't need Hue, we don't need Hive, we do need Flink, and that's we'll throw in Ganglia there as well. That's for monitoring and stuff. All right, and then we can click on Next. We'll throw it into a VPC with a subnet. Let's increase the core nodes to 3. So EMR organizes nodes into a master node, a bunch of core nodes, and a bunch of task nodes. Task is really just CPU and memory. They're doing mostly just processing of the data. Here, we because of the persistence that Flink does, we're going to leverage the core, which does have data storage capacity, and we'll go with the C4 large. Okay. All right. And next, we'll just keep the defaults there. We'll skip the bootstrap actions. That's for customizing it. And we need a key pair so we can get in to SSH. And if you want to customize the cluster's role, we provide defaults, but you can modify those as you wish. You can leverage a bunch of security settings that you've created, if you like, etc. But we're just going to keep things simple. Okay, that's it to launch an EMR cluster. It's starting up. You can see the applications that we've requested. Logging will go to S3. It's trying to provision the hardware, and you'll see that down here as well. So provisioning, and that's it. So EMR is ready to go. All right, now we're going to move on to Elasticsearch. Here we go, Elasticsearch. Okay, we're going to create one called Taxi. We'll call it Analytics, I guess. Stay with that version. Okay. And the instance count, make that 3. And just stay with that instance type. And that's it. Oh, and then we apply an access policy. This is related to security. We're going to reuse one that hang on, did I pick the copy? Oh, here we go. Let's go with that one. So IAM access policies underlie everything within IAS, and it's a very precise, very fine-grained way to control who can access what and what functions on different services. So this is giving us the ability to work with Elasticsearch, allowing any component to work with that. So we're going to use that, and then confirm and create. Okay, there we go. All right, so we've got our infrastructure spinning up, and those things should be ready pretty quickly here. Now, rather than waiting for those to come up, EMR will typically take about 10 minutes or so to spin up all the different nodes and copy software, configure, etc. But rather than waiting for the infrastructure to spin up, I've gone ahead this morning and spun up infrastructure for the demo. So I'm going to go ahead and use use that. So let's go to, okay. So we're gonna SSH into the node, or the master node on the cluster that I spun up this morning. So let me switch to our terminal. Okay, I think you're seeing my terminal now. All right, and so we've got some things we're going to just cut and paste in order to SSH into. Okay. All right, so I need to change my key file. Okay, so this is going to do two things. It's going to SSH into the EMR cluster, but it's also going to set up a SSH tunnel so that I can access the UI, the web UI running on the master node. Okay, so we're in. And so now what I'm going to do is start a yarn session. So let me get that going. I'm just cutting and pasting a command to do that. All right, so this is just, it's running the yarn session that we're going to leverage for Flink. There's no errors here, it's all just info. It's reporting what's going on. This eventually stops. Okay, and then next we're going to download our application that we're going to run on on Flink. Okay, so this pulls down a jar for us that has our custom logic for processing the taxi data. Okay, so we've got that. And then finally, I'm going to run Flink with our jar of custom logic. And what you'll see is it starts to produce some activity. Now, keep in mind, we've got no data flowing into the system yet. So it's really just spinning up, deploying, not spinning up, but deploying the application and running it across our pre-existing cluster. And now what we're going to do is we're going to switch to the, we're going to go to the EMR cluster. Let me switch to the back to the web console. Okay, so stop sharing the. Okay, so you should now see we're back on the web console. Now what we're going to do is go to that EMR cluster that's running, our pre-baked one, I call it. Okay, and so as a result of the tunnel and are using something called Foxy Proxy. It's a web plugin that allows us to send network traffic, web traffic in particular, to, based on ports to a particular application. Here we're now connected to the EMR cluster through the web console, and we have a bunch of applications running on the EMR cluster. So we're going to click that. I'm going to shrink that window a bit, and get rid of this. And then, so here we're just looking at what applications are running on the cluster. And this one is the Flink that we launched. Okay. And so you can see now there's, hang on. Okay, so here's the graph of logic that Flink is operating on. So it's receiving data and then sending it to the three panels, or sending it downstream to what will eventually be the three panels that that we're going to look at. And so, anyways, we're in Flink now, and what we're going to, since it's empty, it's not receiving any records here. Let me shrink this a little bit more. Oops. Yeah, so we're not receiving any records yet, and that's because nothing is going into the Kinesis stream that we set up. So let's now go to let's go into the host that we set up, this bastion host that you saw in the diagram. And so let me grab the command for that. And I need to switch to my terminal. And I'm going to open up a new session. Where did it go? So we'll pop up a clean window here, and what we're going to do is paste this in, and this is going to allow us to SSH into into the host that's also going to run Kibana. But we're going to use this to run a producer that's going to feed data into the Kinesis stream. Okay. All right, so we're SSH'd into that EC2 host, and now we're gonna grab a file, pull down a file, and this is a jar. This is a jar for a producer that we're going to execute this. So you can see it's called Taxi Stream Producer. So this is what's going to generate records that go into the Kinesis stream and here we go, producer command. So I cut and paste this command. So we're going to run that producer jar so that it pumps data. It generates, and what it's doing is pulling data that lives elsewhere, lives on S3, it turns out, the New York City historical taxi data set, but it's pulling it out record by record using event time and pumping those into Kinesis. So let's run that. And pretty soon you'll start to see that it says it's generating records. And now if we switch, we just leave that running. If we switch back to the Kibana, or sorry, the Flink, we switch back to the Flink web console. I grabbed the wrong window here. Okay, so now we're back into the web console for Flink. It's the Flink application, and now you'll see we've got data coming through, all right? And so it's running, and we've got records coming through. Actually, let's take a look at this. Right, so upstream of everything, we've got these records coming through in real time. And then for the last step, we move to the Kibana display. And so for that, we're going to visualize the data. We're going to connect to the Kibana host. So let's, hopefully you can see this, local host. This is also using an SSH tunnel. Okay, so this is the Kibana running on the Bastion host that we set up. And what we're going to do is index on, taxi dashboard. Okay, and create. All right, and so that's just showing us what we're pulling. Now to get a visualization, we need to go to settings, objects, and then we're going to import a JSON file that corresponds to the visualization that we want. Give me a second while I find that. Okay, I got it. All right, so there's a taxi dashboard that's defined, and we're going to look at that. That's our visualization. Okay, and as you saw on the earlier slide, we have a geographical summary of pickups, and so we can zero in. And as we zero in, it gives a finer grained breakout of the regions within New York. Okay. And so, this one more here. Okay, so this is, you can see the legend at the bottom. This is the number of pickups. So this is data that's been streaming through Kinesis, through Flink, passed on to Elasticsearch, and then we have the visualizations here through Kibana. And very quickly, just zeroing in on this. This is the idle time, idle duration for cabs. And as the data continues to stream through, this gets updated, and you can see things. And then we have the graph for the processing, for the time to the cab, for cab trips to the airports. Okay. So one last thing, just to show you, we set this up with a particular capacity, and what we are now going to do is switch back to the web console. All right, and right, so we go back to the console just to show you how we have elasticity for what's needed. We're going to go back to our Kinesis stream, and we're going to enlarge the stream dynamically. So here we have this one here that was set up before, and what we're going to do is drill down into that. Here we have 15 shards, if you remember. We're going to now increase that to 20. Okay, we just changed the open shards to 20, save that. So it's now in the process of dynamically expanding the number of shards on Kinesis. Let's do something similar on EMR, our EMR cluster. This one here. Okay, so let's go down to the hardware. And if you remember, we had three core nodes. So let's change this now to 6. Okay, and what you'll see is it's still at 3, but now it's saying that 6 have been requested. And so now you'll start to see over time, within about 10 minutes, the number of nodes on EMR would be enlarged. And similarly on Elastic Cache, you could expand the capacity there. Let's switch back to the slides, just to wrap up. Right, so if we can summarize, so for predominantly stream processing workloads where you also happen to do some batch processing, Apache Flink has a lot to offer. It simultaneously addresses those 3 major concerns of high throughput, low latency, and fault tolerance. It can do both stream processing and batch processing with a single technology rather than a mix. It's got powerful windowing functions, so it allows you to process and analyze the streams in a variety of ways. It has convenient capabilities to pause, restart, and change Flink applications on the go. Flink's still new, but there is adoption, some serious production adoption. And you know, so maybe it's not quite as far along on the adoption curve as Spark Streaming, but it's coming. And as you've seen, AWS makes it easy to set up and run a streaming workload with Amazon Kinesis and Apache, Spark Streaming, or run Kinesis and either Spark or Flink. Okay, so I think we're ready for questions.
Thank you, Keith, for the great presentation. I want to thank Suman, Bruno, and Tony for engaging the audience throughout our session with the answers to our Q&A questions that have come through. We do have our poll questions open. You'll see 3 at the bottom of the screen, 1 at the top, so we do appreciate your feedback. Definitely thank you for doing that. We will make sure that we look at all our Q&A questions. Again, thanks for everything, and let's start our Q&A.
Yeah, I'll take the first question here. Are there any plans to getting Apache NiFi in EMR? AWS in general is very customer driven, and our product roadmap typically has 90% of the items that come from customers. EMR is no exception, and we will listen to what customers need and try to understand why it's important for them, and then we'll integrate that into what shows up on EMR. So reach out to us if you need NiFi, and we can drill down into some of those details. Second question, hi, will there be a similar demo in a later part of the session for Spark deployment on EMR? There are lots and lots of video recordings of previous webinars that go into Spark on EMR, and there's tons of documentation for Spark on EMR, so I would recommend you take a look at that. Also, third question or comment, but Flink's stable version is 1.2. The one in EMR is 1 version older, where it doesn't have checkpointing, etc. So EMR has a pretty high cadence. We are one of the most up-to-date and current Hadoop distributions available. We're typically 4 weeks or so behind the open source software as it becomes available. So check back in about a month, and you'll see upgrades to the various versions. Those are the three questions I have. If that's all, then I think we're probably done.
Right. Well, thank you, Keith. We do appreciate all your time and effort to put towards this great presentation. And again, I wanted to thank Suman, Bruno, and Tony again for all the great answers to the questions today. So if anybody has any comments on our previous or upcoming webinars or suggestions on topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve